Hello guys, welcome back once again. Today we are going to be creating electronic configuration of elements. In our previous lesson, we discussed the first 20 elements and we gave the symbols of the elements and also the nickname where I use the sum to represent the first 20 elements. If you have not watched it, go back to my previous video and you watch it because it's very important that you watch that video and then you come back to this video. Okay, so now today we're going to be dealing with electronic configuration, and if you understand this electronic configuration, you'll be able to easily know what group um, an element is falls under and what period an element also falls under. You'll also be able to know the valency of that element in such a way that if you know the first 20 elements, if they ask you what group do you think an element with atomic number 15 will be, it only take you 3 seconds to be able to say it. You won't even think much. They ask you what group the element with atomic number of 20, which is calcium, is. You can easily say it, and they ask you what period. Okay, if group will take you like 3 seconds, the period may just take you like 5 seconds to know. It's as simple as that. Okay, so as I said earlier, my goal is to make chemistry very simple for you. Okay, now let's go. In the electronic configuration of elements, the first one will have the first shell, but then we'll have a dense center which is referred to as nucleus. I've also done a video like that before we even did the first 20 elements. You can go back to that, okay, and watch the first, the constituent of element of an atom rather. So yes, here is nucleus, and this nucleus will have proton and neutron, and then we'll have electron revolving around, and that where it is revolving around, we call it what? A shell. Now we said the first shell takes 2 electrons. The maximum electron the first shell can accommodate is 2. Leave it. Okay? Now the second shell will accommodate a maximum of 8. Third shell will accommodate a maximum of 8. Fourth shell will accommodate a maximum of 8, and continuously. Okay? Fifth, 8. Just that the first shell only accommodates 2. Now, in the second shell, just use 0, 0, 0. This is how we represent it. That is, and as I started from here, another one here, another one here, another one. I didn't put 1, 2. No, the electrons has to go around first before we have what? Another pair, because they usually come in pair. Now, the first shell will never come in pair. Remember that it can only accommodate highest of 2, maximum of 2 rather. Then the second one can accommodate maximum of 8. Now we have 1, 2, 3, 4. That is north, south, east, and west. Okay. Now, if you count now, we have 1, 2, 3, 4, 5, 6. If the elements, or let me say, if the elements has 7, that means 1 and 6, right? Then you come here and pair. Put another one here. 7. If it has 8, you come here again and pair. Okay? Then let's count. 1, 2, 3, 4, 5, 6, 7, 8. But remember, I said that before you start pairing, you must have made sure that the electron has gone round, like 1, 2, 3, 4 first, before you start pairing. Having said that, if the electron is 9 in number, that means you have to do what? Write another one here before you have the last one. I don't know if I'm making sense. If I'm making sense, let's continue. Then if the electron has 10, that means you have here, it has accommodated the maximum, which is 8. That means the outer shell. 1, 2, 3, 4, 5, 6, 7, 8. And the inner one, as I mentioned earlier, the maximum it can accommodate is what? 2. 1, 2. That is the shell. Now, this is what we call shell. Okay? What is rotating, mean what is going around is called what? Electron. Remember, we have proton inside here, inside this dense center. We also have neutron inside this dense center. It doesn't revolve. It's only electron that revolves. Alright? Am I making sense? If I'm making sense, let's continue. Now, if you count now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you go to our previous video, where we mentioned the first 20 elements, the element that falls to the 10th one is what? Neon. Right? Because neon has 10 number of electrons, or 10 the atomic number of neon is 10. And we said that the atomic number is same thing as what? Number of proton. And number of proton is usually also the number of electron. Am I making sense? So if proton is equal to the number of electron, that means the number of electrons revolving around here is the atomic number of that element. Okay? So in this case now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that we stated in our previous video, even before the first 20 element, that when we mentioned the constituents of an atom, when we treated the constituents of an atom, we said that the number of proton is usually the same as the number of electron. Why? To make this atom electrically stable. That's why we said atom is electrically stable, because the number of proton is equal to the number of electron. Remember that proton is what? Positively charged, and the electron is negatively charged. So each of these electron has a proton in here that neutralizes it. Okay? So since we have 10 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we have 10 electrons, we also have 10 electrons. We also have 10 protons. And this positively charged, this 10 will neutralize 10, making it neutral. So making what we have here, everything here, neutral. That's why we say it is electrically stable. Hope you understand that. So I will give another one again. Let's say we want to draw sodium. I want us to draw the electronic configuration of sodium. So to draw electronic configuration of sodium, sodium has the atomic number of 11 and mass number. Okay, we don't need mass number, because when we are dealing with electronic configuration, mass number is not needed. Now, for the sake of sodium, we have the first shell. Okay, first shell, and then we have the dense center, which is nucleus. The first shell accommodates 2, as I mentioned earlier. Okay, second shell will accommodate highest of 8. But then if we say 8 plus 2, is it more than 11? Of course, 8 plus 2 is what? 10. It's not up to 11 yet. So we are safe. So we just 1, 2, 3, 4, 5, 6, 7, 8. 8 outside plus 2 inside is what? 10. But we're going to 11. So we draw the next shell. The next shell will have what? 1, making 11. So you can see that sodium has what? Atomic number of 11, and we have 11 electrons. Right? Now, we want to know the valency. This is the valency. 1. The valency is what? 1. Sodium has a valency of plus 1. Remember, in mathematics, we don't say 1x. Instead, we say what? X. Okay? So the same way in this one, we have just plus 1. Instead of writing plus 1, we just write plus. So the electronic configuration of sodium, this is how we draw it. Don't mind the shape. It's supposed to be circle. It's supposed to be round. Don't mind the way that. Don't mind the fact that it is looking this way. Okay. So as I mentioned earlier, this is the exact electronic configuration of sodium. Nothing more, nothing less. The valency is what? 1 plus 1. Why is it plus 1? Because it is having 1 outside. I will draw another one, electronic configuration of fluorine. This is the first shell carrying, and remember fluorine, this is symbol for fluorine, and the atomic number of fluorine is what? 9. If you go back to our previous video, the atomic number of fluorine is number 9 there, and that is the atomic number. So we go 1, 2. Now 9 minus 2 will give us 7. That means we are not going to draw the entire give the entire 8 outside. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see it's remaining 1. And because we are only going to get to 9 because the atomic number of sodium of fluorine is 9. So the electrons, number of electrons there will be what? 9. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the electronic configuration of fluorine.